Okay, so today we're going to sum up everything, all of the conic sections. We're also going to learn how to complete the square, get an equation for an ellipse or a hyperbola or a parabola into standard form, and then from there find all of the important points that we need in order to graph. Now, the first slide here is actually just a screenshot from the textbook, and it's got all of the standard forms and what the graph looks like. Now, let me just go to the ones that are probably most familiar with right now, are these last two are the hyperbola. So again, remember for the hyperbola, it always has a subtraction sign, and the a squared is always first. So for the first one right here, this is the one where the a squared is always first, and notice the letter on top tells you which axis it crosses. Then on the bottom one here, notice still the a squared is first, but what changed is the y squared. It is now first, so this is telling me that my hyperbola is going to cross the y-axis. So be very familiar with the setup of these equations, so that way you can start to eliminate choices. So again, this is just a little review. I highly recommend you make yourself a study guide and make sure you can verbalize what's happening in each type of conic equation. Yeah, like say it to yourself. Like, I know in the hyperbola, it's always a subtraction sign. The a squared is always first. The number or the letter on top of the a squared will tell me where my hyperbola is gonna cross. So things that you could repeat to yourself and explain. All right, so let's look at the first one. This is actually, once I complete the square for this is also going to turn into the equation of an ellipse. Now, we've done completing the square for parabolas. We are now going to do the completing the square for an ellipse and a hyperbola. Now, notice that I have both an x squared term and a y squared term. So the first thing I'm going to do is group my x's together in a parenthesis and my y terms in a parenthesis. So I'm going to go ahead and group the 4x squared minus the 16x in my first parenthesis. I'm going to leave the little blank space that I'm going to fill in for completing the square. And then I'm going to put the y's together. Again, leave a little blank space for completing the square. And then put the constant on the other side of the equal sign. Now, when we did this for the parabolas, when we did it way back when, we did move the constant to the other side. But more recently, when I did this in 10.1, I did not move the constant to the other side. I just shifted it over. But for the completing of the square of the ellipsis and the hyperbola, I am going to move the constant to the other side. So my first step in completing the square is to make sure that there's not a number in front of x squared or y squared. So essentially what we're doing here is completing the square. So I'm going to complete the square for the red one, and I'm going to complete the square for the blue one. So first step is to make sure that there's the coefficient in front of x squared is a 1. So I'm going to divide both of these by 4. So then I'm left with x squared minus 4x. Leave the blank space for turning this into a perfect square trinomial. Then I'm going to do the same thing on the blue. I'm going to factor out or divide everything by 9. So then I get y squared plus 6y. Leave the little blank space, and then it still equals the negative 61. The second step for completing the square is to take the b term, divide it by 2, and square it. And that's what I'll be adding to both sides. So my b term here is the negative 4x. So I'm going to divide it by 2. I'm going to square it. And then I'm adding 4 in my blank space. Now, instead of putting plus 4 with the 61, I also have to multiply it by this coefficient out here, this 4 that I divided. So I'm really adding 16 to this side. And now for the blue, I'm going to take the 6, divide it by 2, square it, and I'm adding 9. Now again, I have to distribute the 9, so I'm really adding 81. I now need to factor the trinomial. So again, I really don't need to figure out what are the factors of 4 that give me 4. If I remember what I got when I divided by 2, that's what number goes in my binomial. And then the same thing for the blue. When I divided the 6 by 2, I got 3. So it's a positive 3. And now I need to add negative 61 plus 16 plus 81, and I get 36. Now, I'm almost there. I now need to get this in standard form. Remember, all of the standard forms are equal to 0, so I'm going to divide everything by 36. I'm going to divide this by 36, and this is what we had been doing before. So now, 4 over 36 simplifies to 1/9, so x minus 2 squared over 9, y plus 3 squared over 4, and it equals 1. So let's go ahead now and let's find all the pieces that we need to graph. The first thing I'm going to pull out is my center point. That's the h and the k. So my center is going to occur at 2, negative 3. The next thing I'm going to find are the vertices. So the vertices are always around that center. So I'm using the center point. Now notice my first term is the x, so that's what I'm adding the a to. So I'm going to add the a to the 2 and subtract the a. So first I'll do 2 plus 3 and then comma negative 3. And then I'll do 2 minus 3 because I'm subtracting the a value to get the vertices. So I have a vertice at 5, negative 3, and negative 1, negative 3. Okay, so next we find the covertices. So to find the covertices, I'm using the b value, and I'm adding it to the y now, because that's where my minor axis is. So for covertices, I'm still using the center, but instead now I'm adding the b plus and minus b to the y. So 2, comma, negative 3 plus 2, 2, comma, negative 3 minus 2. So my covertices are at 2, negative 1 and 2, negative 5. Because again, this is an ellipsis. So remember, vertices use A, covertices use B, focus uses C. I didn't find C. Let me go ahead and go back here and, did I find C? No. All right. Yes.
For this would A always be first and B always be second? Like,
For the ellipsis, A squared is always the bigger number when it's the ellipse. When it's the hyperbola, A squared is always first. So for the ellipse, A squared is always the bigger number. All right, so I guess I didn't clarify what that was. So let me just do that. So A squared is always the bigger number when it's an ellipse. So my A squared was 9, so A was plus and minus 3. My B is the smaller. So my B is the 4, my B squared. So B is plus and minus 2. So now to find C squared, I do the formula. Now remember the formula for the ellipse, it's A squared minus B squared. So C squared is equal to 9 minus 4. So C squared is equal to 5. So C is equal to plus and minus the square root of 5.
Wait, how do you know this is an ellipse?
because it's ended up with a plus sign in my standard form and not a minus sign. All right, so now to find the foci, I use that C value I just calculated. And again, I'm still using the center point, and I'm adding and subtracting the C. And again, it's going to the X, the same thing that I did to create the vertices. So 2 plus the square root of 5, comma negative 3, and 2 minus the square root of 5, comma negative 3. I'm sorry? Yes. So, however, you are going to have to graph it, so we're going to have to approximate. We're going to graph. First thing I can do is graph the center point. So my center is at the ordered pair 2, negative 3. The next thing I'll graph are the vertices. And the vertices are at 5, negative 3. And at negative 1, negative 3. Next, I'll graph the covertices. And they're at 2, negative 1. And 2, negative 5. I have enough, my 4 points here, that I can connect them and graph the ellipse. So it's an oval shape here. The last thing I need to put in is the foci. And again, we're going to approximate it. So what I'm going to do is think about the square root of 5. And the square root of 5 is in between the square root of 4 and the square root of 9. Square root of 4 is 2. Square root of 9 is 3. So it's about, let's say it's about 2.2. We'll just approximate. So when I go over here, okay, so I'm going to approximate square root of 5 to 2.2. So about 4.2. Okay. So this will give me about 4.2 comma negative 3. Over here, if I subtract it, I would get negative 0.2 comma negative 3. So probably about here, and we'll say about here. So those would be the 2 focus points. So again, the red are the focus, the blue are the vertices, the green are the covertices, and the black is the center. So this would be the type of question you would get on that free response. Now, on the multiple choice test, they might give you the standard form and say, find the vertices, or find the center, or find the focus. So again, we're gonna tell you that this is the equation of a focus. Of a hyperbola, or this is the equation of an ellipse. Find the vertices. So on the multiple choice test, it tells you what the equation is for. On the free response, I will clarify everything on Monday. Let's try the completing the square for the hyperbola. All right, so now we'll do the hyperbola. Again, we need to complete the square. So again, we're going to do 2 completing the square questions here essentially. So group the y's, group the x's. So let's see what color. Here we go. So y squared, 4y squared minus 16y, make a group, do the blue, do the x's in blue, or whatever color. So x, oops, I didn't leave a space. X, blank space, equals this constant. So again, coefficient in front of the y squared and the x squared needs to be 1. So I'm going to divide both of these by 4. So 4, and then y squared minus 4y, blank space. Over here, divide everything by negative 9. So x squared minus 2x, blank space, equals negative 43. Again, we need to take that b term, divide it by 2, and square it. So negative 4 divided by 2 is negative 2, and you square it. What we're adding in here is a 4, but when I go to add to the other side, remember to distribute what you factored out. So it's really a plus 16. For the blue, b term, divide by 2, square it. I'm adding a 1, but I'm distributing a negative 9. All right, next, I need to factor the trinomials. So again, 4, and then when I factor this, I get y minus 2 squared over here, negative 9, x minus 1 squared, and then I'm going to add these 3, and it equals negative 36. Again, I want it in standard form, so I'm dividing everything by negative 36. So now this will simplify to y, let me do it in here, y minus 2 squared. This is actually going to give me a negative 9. I'm going to pull the negative sign out in front. Then positive, negative 9 divided by negative 36 gives me a positive 4. Yes.
Are we allowed to, we can't switch it?
We are. Good catch. We are going to switch it so this now becomes a subtraction sign, which is exactly. So now I need to flip these because I can't have a negative term, so I'm going to switch it and write the blue one over here. And now minus the y minus 2 squared over 9, and I have the graph or the standard form of a hyperbola. All right, so this is what I'm talking about it and being able to verbalize this, okay? All right, so a squared is always first in the hyperbola. So let's go ahead and pull these parts out. So I can pull my center out first. So my center is at the ordered pair 1, 2, my h and my k. My a squared is always first, so that equals 4. So a is equal to plus and minus 2. My b squared is second, so that equals 9. So plus and minus 3. Let's find c, and that's where we're going to use the formula c squared equals a squared plus b squared because it's a hyperbola. So c squared is equal to 4 plus 9. C squared is equal to 13. So c is equal to plus and minus the square root of 13. I now can use those a, b, and c values to find the vertices, the focus, and the asymptotes. So for the vertices, remember the vertices use the a. Again, I'm working off the center. My x squared term is first, so I'm adding a to x. So it'll become 1 plus 2, 2, and 1 minus 2, 2. So 3, 2 is a vertice, and negative 1, 2 is a vertice. I don't have covertices here for the hyperbola, but I do have the foci. So let's go ahead and find that. We use the c value. Again, I'm going to add it to the same thing I added for the vertice. So I'm adding it to x. So 1 plus the square root of 13, 2, and 1 minus the square root of 13, 2. I also need asymptotes. So for the asymptote, when the x squared comes first, I'm going to do y minus y1 plus or minus, and then this is going to be b over a, x minus x1. x1 and y1 are the center. So it's really going to be y minus 2 is equal to plus and minus 3 over 2 x minus 1. So now that we have all of our information, we can graph. Yes?
Do we find the co-vertices?
Not for a hyperbola, only for an ellipse. So what's different is the ellipse gets the co-vertices, but the hyperbola gets the asymptote. So let's graph this. I'm going to graph the asymptotes first. So again, start at the center point. So again, my center point is 1, 2. So 1, 2 is my center. And then from that center, I'm just going to rise and run the slope. So my slope is 3 over 2. So I'm going to rise and run from the center, which is 1, 2. So I'm going up 3 and over 2. I can also go up and left to get the negative asymptote. I need to go a little higher here. I need to go up 3. 1, 2, 3, and then over 2. So over here, oops, why isn't it writing? 1, 2, 3, 1, 2, and then up 3 and over 2. So over here, and then I can go down 3 and over 2. And then down 3 and over to the left 2. So here are my asymptotes. I can graph the vertices, the order pair 3, 2, and the order pair negative 1, 2. So again, use the green asymptotes as your guide to see how fat or skinny to make your graph. And then we can also throw in the focus point. So again, the square root of 13 is in between 3 and 4. So we'll say it's about 3.5. So 1 plus 3.5, so I'm plugging it in here. So 1 plus 3.5, comma 2. So I'd graph the order pair 4.5, comma 2. About here. And then I could also minus it. So I'm just going to make it the same distance away. So put it about here. So that is the graph of a hyperbola, or using completing the square to get it to standard form, and then finding the vertices, the focus, and the asymptote. The last one is a parabola. This is a review of 10.1. We did this, we spent a whole day on doing completing the square of the parabolas. I know it was a while ago. Example. Again, it's a parabola. When we did the completing the square for the parabolas in 10.1, we want to get the non-squared term by itself. So I'm going to move the x squared to the other side. I'm going to do this step by step so nobody gets lost. I know you guys could probably move it all over really quickly. I'm going to add the 6x and then get 8y minus 7 negative x squared plus 6x. Add the 7. I'm trying to get the non-squared term to be all by itself. All right. Now, next thing I want to do is make sure that the squared variable is like grouped together. Remember, the coefficient in front of that squared term needs to be a 1, so I'm going to divide everything by -1. So now I have 8y is equal to -1, x squared minus 6x, blank space, and then the constant. Now, when we did this before, we were moving the constant to the other side. But when we're dividing out something to make that x squared term positive, or a 1, it's easier to keep the constant just shifted over. So now I need to, now that I have a 1 in front of the x squared, I take the b term, divide it by 2, and square it. So I'm adding a 9. Now, when we don't move the constant to the other side, I'm doing opposite. I should be adding a -9, but I have to distribute it. So what I was thinking I'd be adding is a -9, but I do opposite because I didn't move it to the other side. So I'm not undoing an inverse operation. So now I'm gonna add the constants. I'm gonna factor the trinomial. So again, you don't need to really think about the factors in 9 that give you -6. Just remember the number you got when you divided by 2. So this becomes x minus 3 squared plus 16. The next thing I need to do is to get y by itself. So divide everything by 8. So I now have y equals -1/8 x minus 3 squared plus 2. Now, the standard form that I'm working for the parabolas is going to be the square term. So I'm going to try to get x squared, or x minus, let me write it with h. X minus h squared is equal to 4p y minus k. This is what I'm trying to make it look like. So here's what I need to do. Move the 2 over. That's going to become my k. Now, I need the square term on the left. So again, I'm going to flip-flop. I'm going to move that to there and that to there. So I'm going to, and this has a negative in front. So -1/8 x minus 3 squared equals y minus 2. I now need to only have this. So I need to get rid of the 1/8. So I'm going to multiply both sides by its reciprocal or divide by 1/8. So now my standard form is x minus 3 squared is equal to -8 y minus 2. I can now pull out the center. So my center is at the order pair 3, 2. I need to find another point, or actually no, this isn't my center, this is my vertice. Sorry, this is the vertice now, because it's a parabola, or the vertex. This is the vertex. I now need to find another point so I can graph my parabola. It doesn't matter what you plug in. Usually finding either the x or the y intercept is the easiest. So because my graph is the graph of upside down because of the -8, I'm going to go ahead and find the y-intercept. So I'm going to set x equal to 0 to get my y-intercept. So 0, I'm plugging it in here. 0 minus 3. Usually when it's in standard form, like ax squared plus bx plus c, it's easier to plug it into the original. But my original was a bit much, so this is why I'm going to plug it in here. So plug it in, solve for y, so 9, distribute the 8, move the 16, get negative 7 equals negative 8y. Divide by negative 8. And my y-intercept is at the ordered pair 0, 7/8. I now need to find the value of 4p. Remember up here where I showed you the form we were trying to get it to, the negative 8 equals 4p. We did all of this before spring break. So 4p equals negative 8. I need to find the value of p. So p is equal to negative 2. The focus. I'm going to take the center, or the vertex. Remember, the p-value is the distance that the focus is from the vertex, and it's also the distance from the directrix. So again, this is an upside down U. So my focus is going to be, I'm going to add it to the y. Okay, so then my focus point is going to occur at 3, 0. And my directrix, I'm going to, remember it's an equation. It'll be y equals, so now I do the opposite of p. So it's 2 plus 2. So my directrix equation is y equals 4. Now that I have all of my information, my equation for my directrix, my focus point, and my vertex, and my y-intercept, I can graph my parabola.
In class. All students should be in class. Please return to your classrooms. You will be called down to the gym. Return to your classrooms. Thank you.
The graph of the parabola by finding the vertex, one additional point. Generally, it's easiest to find the x or the y-intercept. I found the y-intercept. And then from there, you need to find the focus and the directrix. So again, this example was done in 10-1. We did several examples before spring break. So if you've forgotten this, you can go back and watch that video. So the homework for this lesson is 13 through 35. Again, all they're asking you to do in this homework is to identify what the equation creates. Again, I highly recommend you practice completing the square because you will have to do this. You'll have to do this probably on the free response question and then also again on the SAT. Good?